All right, so for 10.5, we are looking at something called the activity series and using it to determine if a single replacement reaction will occur. So you've seen a number of single replacement reactions. This was the reaction you worked with in the lab, where I gave you an element, which was a coil of either silver or copper, and you put it into a solution of either copper sulfate or silver nitrate. And both of those reacted. So kind of leads us to the idea that, oh, single replacement reactions always happen, which is not true. I can definitely take that same coil, put it in a different solution, and absolutely nothing will happen. It will just sit there and do nothing. So learning target 10.5 is figuring out, well, how do I know whether something will react or not and how that works? So this is called the activity series. It's not something you have to memorize. We will give this to you. You just need to be able to use it and interpret it. So we have a list of the metals from most active to least active, and a list of the nonmetals from most active to least active. And this is really based in periodic properties, actually, as to thinking about whether metals or nonmetals are trying to gain or lose electrons, and the pull from the nucleus, and how easy it is to give away that electron, or how much energy it needs to do that. So there's a structure reason behind this list. So and I've already gone through the notes, so I'm just going to talk through them. So what we need to do is we're going to predict whether the reaction will occur and justify our answer. So what I have in the box is really the thought process. It's a scaffold to kind of think through it. Really, your answer will be that justification. It'll be yes, it reacts, or no, it doesn't, and then telling me how you decided that. So when I'm looking at these two, I'm always looking at whether the element will replace the thing in the compound. So I'm looking at the sodium, and I have to think about, well, is the sodium going to replace the zinc or the chloride? Well, it's going to replace the zinc because they're both positively charged. So that's what I'm going to compare it to. I'm going to compare the element to this thing with the same positive or negative in the compound. So I'm comparing the sodium with the zinc. If I look back at my activity series, I can see that sodium is here and zinc is here. So sodium is more active than zinc. So what I do with that is, so I've got sodium that's more active, and what that means is because the thing in the element is more active than the thing in the compound, it will react. So one of the other ways you can think about this is the element that is more active will end up in the compound. If it starts in the compound, it'll stay there. If it's not in the compound to begin with, it's going to outcompete the other metal, in this case, for those anions and turn into a compound. So my justification, it really has two parts. It's my evidence from the activity series of saying, okay, sodium is more active than zinc, and then why that matters. So that means it's going to replace the zinc. So really interpreting kind of the reasoning as to why that evidence tells me that it's going to be a reaction. So yes, the reaction occurs because sodium is more active than zinc, so it will replace the zinc. All right, so if you want to try the next one before I advance the video there, you can go ahead and pause the video and then pick it up again when you're ready to check your answer. All right, so for this one, aluminum and calcium chloride, there is no reaction because aluminum, the thing I'm comparing it to is the calcium because they're both positively charged. Doesn't matter that one's a 2+ and one's a 3+. That's not going to matter for deciding who it replaces. So looking at the activity series, aluminum is not more active than calcium. So will a reaction occur? No, it will not. And so my justification is that aluminum is less active than calcium, so it will not replace the calcium. All right, and then I'll look at the last one. The last one has to do with nonmetals. So we can also look at nonmetals. In this case, we have fluorine as the element, comparing it to the chlorine in the sodium chloride. So again, the negative thing will replace the negative thing because we need an ionic compound on the other side, which is going to have a positive and a negative charge. So I'm comparing fluorine and chlorine on our activity series. And fluorine is of all four of those, the nonmetals, it's the most active. And you can actually, if you look at the periodic table, you'll notice that they're in the same order that they are on the periodic table from the top to the bottom. Again, you can see a tie back to periodic properties. So this one will occur because fluorine is more active than chlorine, so it will replace it. And that is activity series, and you can work on that last worksheet.